Hi, in this video I'm going to briefly present the the proof of concept that I've been working for the last couple of days, especially this weekend. This is an example of an application built using the event source and CQRS approach. Um, Event source and CQRS. I believe you've heard uh, those terms quite often these days. But if you don't and you want to find out more about it, I would recommend this book from Microsoft called CQRS Journey. So yeah, this is a really complete, comprehensive book on this topic. So this application is in Golang. It is uh, built on top or using a messaging library. Should I call it messaging library? A framework or a library called Watermill, which is actually a library for building a message-based application. So it provides as abstraction for consuming or publishing from or to different type of source or sync of messages, be it a Go channel, RabbitMQ, HTTP, Kafka. It has a couple of pub sub implementation or abstraction. And on top of that, it also provides building blocks for building a CQRS application. Those building blocks are like the command handler, event bus, command bus. Yeah, so those are just for the basics, for the plumbing, connecting the messages between the Kafka topics or RabbitMQ queue or topic to specific handlers in our domain logic. So it's not complete. In order for to have like a robust production ready event source CQRS framework, there are a couple of concerns that need to be addressed, like aggregate locking, multi-version concurrency control. What else? Command deduplication. So those concerns or those ideas, I learned it from another CQRS library, which is in JavaScript, called this one Node CQRS domain. So it has things like aggregate locking. It has the duplication of message. Yeah, it depends on Redis for quick to have the locks there. What else? Multi-version concurrency control with the revision of the aggregate and things like that. Yeah, so the idea is built married together this library with some ideas borrowed from this library in order to complete our solution, right? Yeah, and apart from those concerns, this framework or library also offers the way to structure your code. So you have a separation between, okay, you have a code for validation, you have a code for preload conditions, checking if the command can be handled even before we get an access to underlying data database. So it's just some preliminary checking maybe based on the values in the comments, and then you check, and then you load the data, the existing data, check its values and the values in the command, and by some logics you decide, okay, should this move forward or no, and then finally you handle the command, and then the command emits events, and when you apply an event, you modify the data in the database. So this is the flow that we need to have in our code, in our domain code. What else? Yeah, so this library, these ideas, which if you're curious, this is open source, and this is the company that is currently provides of commercial backing, like support and stuff, to this project. And if you're in Java, there's this is very robust and battle tested CQRS framework called Axon. Now that we're in Go, this is what the best that I found so far. So that's why I built our solution based on this. All right, so just without further ado, let's see what we have here. So we have for this proof of concept, I separate this into 3 applications. The first one is this publisher. It simulates incoming requests. So this is how it started, right? There's a request, and this request is transformed into a command, and this command is pushed into the Kafka to be handled by the command handlers here inside our processor. So in this processor project, where we actually have our domain logics coded, right? And the third one is event denormalizer, or you might want to call it a view builder. So the idea is with the CQRS is you have one write model that is this one. This writes to database where you store your aggregates. But you can have multiple views to the state of your system. So for each views, you will have to build this event denormalizer or view builder, which consumes events or specific events from the domain, and you build your view, your materialized view, whatever, to your needs, according to your needs or to your hard content, right? So in this case, we only have one view builder. So what is the domain here? The sample domain here is a hotel. So we have this set of command and event. We have command called book room. We have event called room book. We have command name order beer, and an event name beer ordered. So each one of those things has this header where we store information like the ID of the command name, and this is very important and interesting. The correlation ID, for example. So let me just go quickly over the logic, right? So first, there's a command, the bookroom command, and this will trigger, in the handling of this bookroom. You make some decision. Okay, fine. We accept this command, and let's generate a room book event, right? Now, with this correlation ID, we can at later point, when we, for some reason we need it, we can see that this event, this room book or the booking of room, was caused by this command. And yeah, so that's just one simple example. There's just two things in the chain, but in not non-trivial process, you might have like, I don't know, more than two, maybe five, six points in the chain, command events, command. Then you can see that thanks to the correlation ID, which is set on first, yeah, once on the first message, whether it's a command or event, and then it is copied throughout the chain. Then we have aggregate ID. So the idea is a command acts on an aggregate. So aggregate is something, a term or a concept that we learn, or we need to learn from domain-driven design and analysis. So actually, the event sourcing on and CQRS concept itself is pretty simple, but the challenging part would be to identify the aggregates that make up your system. So aggregate is like an object with I don't want to get lengthy into this, but a command acts on an aggregate, and an aggregate as a reaction to the command, it will emits an event or some events or several events. So there's a binding between a command, an event, to an aggregate. So that's why we have the aggregate ID and aggregate name or aggregate type in the header of the message. It can be null, but once thing starts rolling, aggregate is created, and then the subsequent event or command will have this ID. This aggregate revision, currently in this code, I'm not using this because I haven't implemented the multi-version concurrency control that we're going to have. In soon, this weekend. And process ID. This is also there's also another concept called process manager or Saga in the CQRS. Let me see. Process. This one. Saga. So for this basically it's a workflow. So for non-trivial cases, we don't want to have the logic scattered over the aggregates. We want to concentrate them in one single object. So that one single object would be the process manager, which so it acts on command or event in this. I think. Wait, no. This is not the diagram for process manager. This is the diagram for process manager. Place order. Okay, yeah. This is the process manager. So instead of having the user looking for the correct aggregate to manipulate or to act on for certain scenarios, you put that decision in the process manager, and it takes charge of finding on each step which aggregates to manipulate, right? So events in, comments out to the aggregate, and events goes back into the process manager, and so on. So we have basically we have a workflow there. So this is what the process ID is for. Currently we are not using it either. So by next week we'll have this process manager and multi-version concurrency control implemented. And the last one is the version. This is a tricky part. Of course, as the business grows and new scenarios discovered or invented, maybe we need to extend our command with some extra information. So we're dealing with now with evolution of command or event. So we have versioning here. So this version information can be useful in our handler in code to make some decisions. Okay, if the version is version 2, then do this. Version 3, do that kind of thing. And okay, the last one, the domain. Okay, for in this case, the domain. Let's say the domain is hotel booking domain, right? The booking domain. And let's say in the company there are multiple domains, and so the booking, maybe the accounting, and then other what else? The transport, maybe taking in or taking out guests. So we have several domains. So usually they will translate each one of the domains will translate to a microservice. Now, an event generated in one domain can go crossing to another domain through the Kafka. Given that the other domain connects to the same topic where the events are queued. So that's how we integrate different microservice, right? Now, this origin domain allows us to have complete traceability. So it's not just a traceability within the domain using this correlation ID, but we can also connect the dots between things that are happening in one domain with things that are happening in the next domain. So this is what the origin, this information in the header is for. Okay, so yeah, I've explained the command event. The code here. So we set up our engine here, basically, where we specify what are the command handlers, what are the event handlers, how the handlers connect to the Kafka topic from which it will consume the messages, how it will connect to the Kafka topic for publishing comments and things. So this is where we do the plumbings, right? And the logics are here in handlers. Bookworm handler, for example. Okay, in this case, so please note that inside the command handler we don't actually manipulate the state of the system. We don't go into the database, load and aggregate, modify it, and save it here. Not here. What we do in the command handler is decide what events should be generated as a reaction to that command. So these events is something something that we would call los hechos in Spanish. So so when we talk about replayability or reproducibility, we're not replaying the comments later on. What we will replay is the events, los hechos. So to rebuild the state of our system. So so that's the core idea. So I also made the same mistake coding the manipulation inside the command handler. So no, just make your decision on what event should be generated or log, And then in the event handler, there you get a chance to load the aggregate, modify it as necessary, and save it back to the storage, right? Now that I mentioned log here, so basically the events are the log of what happened to your system. So this is also related to, should I call it frustration? Frustration. I mean, we do lots of logging, and it's just very difficult to enforce certain how you should write your log message, how you should redact your log, and even if you manage to define a very well scrutinized log message throughout your code, still you will have to shift through those text messages in the log accumulator, and well, maybe in Elasticsearch, if you log as a JSON, probably you will be able to do some ad hoc querying. Yeah, but here, by doing event sourcing, you get the logging for free because the events are basically the logs. Yeah, with all the benefits that I've just mentioned, you can you have the correlation, you can trace it inside a domain or across domains. This is also one of my motivation to push this event sourcing, because we're just tired of inadequate loggings in our system, or afterthought loggings that is done as an afterthought. Oh yeah, we're missing some logging here. That happens after some problems occurred in the system, right? Now with event sourcing from the get-go, we get the logging that also works. That makes our system works, right? That function. What else? So you okay? The command handler, the event handler. Here you modify the aggregate, and then yeah, this is the chain. From here we issue another comment, and then we handle the order beer comment. What we do here is generate another event, or order beer new. Oh, I made a new beer order. Yeah, I made a mistake here. Cool. A new beer order. Okay. Then beer order, it's handled. What we do in the beer order is just add extra charts, right? Now the final one is our view builder here. Yeah, it's the same. It's basically an event handler. It consumes what events do we consume? The room book event. So it's not complete. I mean, I think we also need to consume the beer order event, right? Because yeah, we modify the charge there. The idea of this the normalizer is we keep track of the amount of money that we have amazed throughout the the running of our system. So the total money is stored in a table named financial booking, which is very simple. It just have an ID, which is the ID of the company and the total amount of money. So here we don't need all the CQRS machinery or the plumbing, because it's just a simple consumer that takes message from Kafka. So the code is a bit simpler here. We just have to define the Kafka, connect Kafka here. Yeah, we subscribe to the events topic, and subscribe process. Yeah, and then we filter the message. We are only interested in this event, so Marshall, yeah, and we transform the Kafka message to a CQRS message, because here it's just Kafka message with the bytes and things, and we transform it into this type room book, and then yeah, we finally pass it to the function that does the logic right here. Fine, we load the financial booking for the company. We add some amount to the total, and then we save it back. Okay, so without further ado, let's just run the application. Let me first build it. Okay. Bam. Okay, now we're publishing lots of comments. They go to here. Oh, 1 second. Yeah, here. Currently, there's no process is consuming this comment. What else do we have here? Order beer, of course. No, we don't have any message, because order beer is generated as a response to the book room, and currently we're not processing the book room. And events, there's no events as well, because yeah, event is also the outcome of first processing of a comment. So let's just run the processor now. We're going to now that because we have 2 partitions in those topics, so I'm going to run 2 instances of the processor. This and this. Okay, so as you know, what top key, duplicate key. Wow, what's going on here? Give me a second. Interesting. Having an error in a demo. This error happened when after I changed beer or aggregate ID correlation. Multiple write errors. Duplicate key as a reservation. Oh. Wait a second. The main partition, like 37 new order beer handler. Beer order handler. Oh, wait, what is the second? New beer ordered. Beer ordered. Okay, fine. Beer ordered. New beer order. Beer order handler. It handled the beer order. Handling word or event. I'll stop this producer first. Error handler. Multiple duplicate key error collection preservation. Duplicate key. Oh, right. Of course. Oh, yeah, this is the error. I need to implement upsert instead of insert, so I think I have it here. Wait, no, here. Save, save, save. Where is it? Where is it? Absurd. Hey, no, wrong. Here. Oh, there you go. I'll just copy this. Boom, boom. ID filter. Reservation ID. Yeah, right. Reservation ID. Set reservation. Absurd. Yep. That's all. Actually, just change the insert to absurd. Okay, so let's start clean. Yep. So I'm going to delete those collections. I'm going to delete this. This is also another thing. We need to make sure that we don't need to do this whenever we fix a bug, or of course, or add some features. Maybe we need to deal with the concern of reprocessing. We fix a bug. The bug starts on specific points, like specific events. We need to go back, like time travel. That kind of thing. The undo. No, but that's too low level. Usually in the CQRS we try to emulate the real life. So what we do in real life, instead of doing a rollback, we're accustomed with the RDBMS mindset. Oh, something's wrong, so let's just do a rollback. Now with the event sourcing, we don't have that, because we're dealing now with distributed system with eventual consistency, and so there's no such thing of. It would be too expensive to do like distributed locking like that, right? So what we do is we have to define like the compensating operation. We need to define compensating command to undo some operations, things like that. So yeah, that's difficult, but I think that kind of challenges we'll have to face it in any with any approach to software development, right? Here in the event sourcing or CQRS, it's just made explicit. You need to define your undo operation, your compensating operation. Okay, let's remove this. Did I do that? Yes, I think so, but just in case I forgot, remove all back here. Now I need to delete this topic as well. Delete, 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 new events to main, to main, to 222. Perfect. Run. First build. Boom. Then run. Boom. Run. Run. Okay. Cool. Now we don't have the problem. That problem now. Now let's see. This first instance of the processor only deals with 11, 13, 15, 17. it doesn't overlap with the other consumer 12. So yeah, that's the idea of Kafka with partitioning, right? With the consumer group. So each member of the consumer group uh, uh, receive a subset of the message in the topic, right? Which is partitioned based on the partitioning key. Now, speaking of partitioning key, this is also one important topic to discuss, because especially with events, you want to make sure that those events are execute a process in order they were created. But how do we do that with the partitioning in Kafka? If we only had one partition, then there wouldn't be a problem, right? But now we want to scale, we need to partition. How do we still ensure that there's some order? Now, so the key here is to define correctly the partition key. So this way, for the events especially, you want to make sure that all the events that are supposed to be chained together in order, they need to go to the same partition. So with that in mind, you devise your partitioning key logic. In this case, I simply use the aggregate ID, because I think that okay, so events will modify an aggregate, so I think it's logic that we use the aggregate ID as the partition key for the event, right? Because that was my logic. For some other scenarios, probably the partition key could be more complex with a combination of some different fields. I don't know. So yeah, we need to keep that in mind. Okay, so we have that. I also add some code to store those commands and events in the database, in this case in this Mongo database, in this table. And now let's see the correlation ID in practice, right? Let's open I'm looking, okay, this one, exactly. So we have the room book event. We know that the room book event is an outcome of the book room command, right? The result of processing the book room command. So now we want to know, okay, what is the command associated with this event? This is where the correlation ID helps. Copy value, find header correlation ID. Oh, sorry. Correlation ID. Boom. So it's confirmed. We have this room book and we have this book room. Cool. Right? So this is the ID and this is here. It appears as the correlation ID. And we also know that this room book acts on this aggregate, the aggregate with this ID. So let's find it. The reservation aggregates are stored in a table or in collection name reservation. So let's find ID. Boom. John. Room ID 10. See, room ID 10. Correct. Cool. Now let's go to the final part, which is the view builder. Also run 2 instances of it. Boom and boom. Okay, now it's split. Now we can see the result in financial bookings for the company named VOC. That's a Dutch East Indian company, which was touted as the biggest company ever in the history of humankind, like the first multinational company, and they made their big fortune by the spice trade, which is of course involves some colonization. How sweet. Right, I'm just so interested in some part of the story. Okay, yeah. So we see the total increasing here. That's the result of view building. What else do I need to explain? Oh yeah, the repo. So if you're interested, again, I would suggest you to read this book from Microsoft. There's also another book. If it's a very old book actually, the from Eric Evans, the Domain Driven Design. That's a blue book. I also had it, but I lost it. I bought it like where more than 15 years ago. But there are newer books now. There a book from Paul Vernon. Domain Driven Paul Vernon. Yeah, this one. Either this one or this one. I think I have this one. So, yeah, for the part of the analysis, like identifying the aggregate, identifying the commands and events, there's an analysis technique called event storming. Oh shit. Yep. And I found compared to the unified modeling with with object oriented, I found this is more natural for me. It's just closer to the way we think in the real life, or business persons think in the real life. So they think in terms of events, in terms of documents, which we can translate maybe to aggregate. Yeah, events, and then you work back. You define, okay, for these events to happen, what commands need to be there, right? So that is what the event storming is about. What else? Yeah. So if you're curious, you can go to this repo in GitHub and check out the code. And I really hope that we can push this architecture in our company, because I do believe that this will this will improve our code, our life as well, because now we have like a better view of what things that are happening in our system. So yeah, please check out this code and check out the books or articles, and we'll be in touch. Okay, see ya.